Hello, everyone. Thank you for joining us for this webinar today. And we are about to start in a few minutes. We will wait 1 or 2 minutes for more people to join, but everyone is welcome. Welcome to this webinar where we will be presenting our new products, our new offerings for the desktop systems that we call Desktop Anisoprinting. This is the new product offering that we have released last week, and I think most of you have seen the press releases in the media regarding this offering, and that's why, all of you here were invited to have a better look into the new products and new services that we are introducing. With this webinar, I will explain in more detail what is actually desktop Anisoprinting and what we are actually offering here, what's new, and what is basically the concept of this new solution. So we are ready to start. There are still people joining us. Everyone is warmly welcome, and thank you for being with us. I think, I could start. So, as I said, last week we have announced the launch of our new offering, which is called Desktop Anisoprinting. We call it a turnkey continuous fiber 3D printing solution. So basically everything that is needed for a successful experience with 3D printing with continuous fibers. What is included in the offering? First is, of course, the hardware, the 3D printers that we offer in this desktop format, so that the Composer 3D printers that we have in 2 available options. The Composer A4, a smaller machine with a build volume of 300 by 210 millimeter, and the Composer A3, which is twice the build area, the bigger machine. These are there is nothing new. These are the machines that we are selling and shipping worldwide for 2 years already, and I think some of you are already experienced with these machines, and you know a little bit about the hardware and the technology, so there is actually nothing new. The second part of the offering is, of course, materials. Here is still the 2 parts of it. So the reinforcing fibers, the composite carbon fiber that we are also offering since 2 years. So this is our high performance reinforcing material that is used on the Composer systems. There is also a second material that we offer, is composite BASALT fiber, which is an alternative to carbon. It is it has a slightly lower performance compared to carbon, so less strong, less rigid, but at the same time it's a cheaper alternative, and it's also non-electrically conductive and radio transparent. So so far, there is nothing new. We have these products on the market already, and you should be familiar with some of them. And now there is the first new thing, the first new offering, new product is our branded new plastic materials. So you all know that Composer is an open system for plastics where you can reinforce different types of plastic materials, of third-party plastic materials to make high strength and stiff parts. But with the desktop Anisoprinting offering, we start introducing our own plastic materials, which are called CFC PA and smooth PA. So here I will go a little bit deeper to explain why we are introducing these materials and what's special and unique about them. As you know, yeah, the technology that is used on our desktop machines is called composite fiber co-extrusion. And here you can see the schematics of how the technology is implemented. So basically, to print with composite material, you need two inputs, one input for reinforcing fiber and one input for plastic material. They are combined together in the print head and extruded together to form a D-matrix composite. So this is how the technology works. So the first material that we offer, the CFC material, the CFC PA material, is a specially formulated plastic to use in the co-extrusion nozzle, in the composite nozzle, together with one of our reinforcing fibers, either CCF or CBF. So this is how actually the print head of the composite machine looks like. It actually has two nozzles. The right nozzle, the right one is the composite nozzle and the left one is the plastic nozzle. So normally to print on composite machines, you need 3 spools of materials, 2 plastic materials, one of which goes to the plastic nozzle to print with plastic extruder, to print exterior shells, top bottom layers, plastic infills and supports. And another plastic filament is needed for the co-extrusion nozzle to print high strength and high stiff composite material together with reinforcing fiber. So Composer is an open system where you can use different types of plastic filaments for either plastic extruder or composite extruder. So the 2 new materials, the CFC PA and the smooth PA, is the special offering that we have developed specifically for plastic extruder and composite extruder to achieve certain results. So the CFC PA material is used on the composite extruder together with the composite fiber, and the smooth PA material is used on the plastic extruder to print non-reinforced entities. Why we need these 2 materials and what are they actually offer? So the CFC PA material is a specially formulated polyamide based on PA12 material to ensure a good adhesion and good wetting of the fiber when printing with the best reliability and printability together with our fibers. And the smooth PA is the special material for plastic nozzle, which is also a polyamide based material. It's also based on the PA12 material, but in this case, it's a chopped fiber infused material, carbon fiber filled PA12, and it ensures a perfect surface quality and ease of use and good smooth surface finish, very good supports, very good breakaway supports, and printability and ease of use. And as it's based on the PA12, it doesn't absorb moisture, so it can be printed without a drying box. These 2 materials were specially developed for us by our long-term partner, Polymaker, a well-known expert in 3D printing materials for FDM. So these materials are white labeled, especially, and co-branded, I would say co-branded for us by Polymaker. So since the release of Desktop Anisoprinting, in every box of either Composer A4 or Composer A3, there will be one spool of the CFC PA material and one spool of the smooth PA material and one spool of fiber. So 3 spools provided by us, and of course you can get also these materials from us or from our partners worldwide to print with these materials. I will spend a few more minutes to show you some of the examples of the smooth PA surface and how it looks like. So for us, it was really important to offer to our customers a reliable and easy to use way to start printing with continuous fibers without getting too much deep into the settings and into tuning the settings, tuning the parameters. So for the smooth PA material, our engineers have developed a fine-tuned material profiles that will be available in Aura, so that it will not require any effort when using these materials to print and to achieve a good surface finish and good material and good surface quality. So this is actually the main feature that chopped fiber infused plastics can give. So they are not actually bringing too much of the mechanical properties such as strength and stiffness, but they can, by using the chopped fiber, the layers are the visible surface, the side surface structure becomes more smooth because of the chopped fibers pointing out. So I also have one part here in my hand, so you can, if you look at the video with me, you can see how the surface is actually looking in a actual part. So here you have the picture on the screen, and here you can see some examples of this surface finish that the smooth PA material is giving. There is one more example. These materials will be available since mid-November to order and for shipping. The third important part of the desktop Anisoprinting offering is, of course, the software, the Aura. The Aura 2.0 will be available quite soon on our web page to download. It will include a few more features, some updates, some improvements, and of course, most important, it will include a wide range of printing profiles for materials that are available for using on our system. Of course, there will be profiles for smooth PA and CFC PA, and there will be a bunch of material profiles for third-party materials that are also possible to use on our system. The fourth part is, we believe, a very important part is the education, the training courses that we have developed for our users. The training courses are divided into 3 levels. The first level, the basic training course, which includes introduction to Anisoprinting, composites, basics and design, introduction to slicing software, different types of plastics and hardware operation, is already available on our new web page for everyone. So everyone can check our new web page and find the section dedicated to the training courses. I will quickly switch to my web browser to show how to find it. Here's our new web page with some new tabs and new structure. Here you can find the learning section. Watching, it's a video course available on our web page, and 2 more courses that we would provide on request. There are also a number of new use cases that you can find on our web page, and I also wanted to share some of them with you. All the new use cases that you can find on the web page are made with these 2 new materials to demonstrate its performance and its benefits. So here the first one is the bike rocker, 3D printed in 2 pieces on an Anisoprint Composer A4 machine using the CCF composite carbon fiber with CFC PA as a co-extrusion material and smooth PA as a plastic material, and compared to the original aluminum CNC part, there was a 35% weight reduction and almost 40% manufacturing cost and reduction possible with using the continuous fiber printing technology. Another use case is from tooling. So it's the soft jaws, a special type of jaws for turning, fixing the tube inside the pattern with the soft jaws without damaging, especially if it's a thin tube. Standard metal jaws would significantly, with high forces, there is a high probability to damage the part that is being machined. And with the composite material, with the plastic shell, it's a really soft material, and at the same time the part itself is very strong because of the fiber reinforcement, and it will serve for a long time because of its increased mechanical properties. And here there is also a huge potential of saving costs and material usage. Third use case is also from the tooling segment. It's stamping tool for fan blades made with continuous fiber, also with a smooth PA and composite BASALT fiber, showing a significant reduction in material usage, weight, and cost and time savings. You can find more information about that on our webpage. And another use case is from the end-use parts. So it's the robotic system, leg for the inspection robot, which was manufactured with our new materials, the smooth PA and the continuous carbon fiber, replacing standard traditional aluminum parts by saving the weight for almost 4 times and almost 2 times the price. using the continuous fiber printing technology. This is it from the presentation. I think we have some time left, and if you have any questions, I encourage you to raise your hands, and then or you ask your questions in chat, as we did it on the webinars before, and I should be able to answer your questions if available. So please feel free to ask your questions in the chat or by raising your hand. I see there is at least one question available. Question from Joshua. I'm actually thinking about getting the A3 now, looking at those sexy smooth surfaces. Thank you. I hope there is a bunch of new materials coming out from Polymaker and co-op with you. Their stuff is just top shelf. Sorry, but PA is highly moisture absorbent, so it's really not good to be used in a CNC machine. Yeah, as I mentioned, thank you for your comments. We really appreciate it, and thank you for your kind words. Then, as I mentioned, both materials, the smooth PA and the CFC PA, are based on a PA12 material. So that's one of a few PA grades that actually has a very low moisture absorption, less than 0.5% equilibrium moisture absorption. So it can be really used to print without drying. So of course there will be some difference if you use a dryer and if you are not using the dryer, but it's not really significant, that it's hardly visible in most of the cases. The main disadvantage of the PA12 compared to, for example, the highly popular PA66 is a lower mechanical performance, so it's not as strong and not as stiff as PA66, but in continuous fiber printing, continuous fiber is what's actually bringing in the properties, is what's actually bringing in strength and stiffness. From our point of view, the plastic is not responsible in this case for mechanical properties, but it's responsible for the surface properties, such as surface finish and chemical resistance and frictional properties and other ones. So in this case, we are pretty sure that PA12 is a very good choice. So it's easy to print with, and it provides good quality, good printability. It's not as strong as PA66, but strength is defined by the continuous fiber. So I hope I have answered your question. So there is more and more questions coming. Question from Inma: I need more details about produce functional parts for bicycles. Okay, we can discuss it separately. If you can write me to your email, I can provide you more information about this particular use case and the interview with the manufacturer and with the user, and we can discuss it. That's a very good question from Clement. For the bike rocker, was the reason for two-part design? Yes, it's if you look, let me get back to this use case. Yeah, if you see, it actually has two surfaces with holes. Yeah, and in this case, the part was printed. Unfortunately, I don't have it with me here. Yeah, but the fibers are aligned in the plane of the holes. Yeah? So if you look at these two parts, so it was printed like that. So fibers are put such as that the holes are reinforced around. And in this case, the interlayer strength would be not enough for this part to work on bending of the two parts. So in that case, the fiber should go from in this junction part. The fibers should go across the layers. So we've redesigned the part to cut it into two parts and connect it with bolted joints, so that in case of this type of loading, all the forces are transmitted to the bolts, and fibers work for loading the holes. I think I've answered your question, I hope. The minimum wall thickness, it's a very good question. So with the CCF, the minimum fiber path, so the fiber has the carbon fiber has the thickness of 350 micron. It's a round shape, so it has a diameter of 350 micron. When we print it together with plastic, the fiber is a little bit squeezed to an elliptic shape, and there is a little bit of plastic added around the fiber. So the single fiber print has a width of 700 millimeter. But if you want to print a thin wall, in this case, the fiber will be always surrounded by a thin plastic shell. So that's basically how the algorithm works in Aura. So there will be always at least one plastic shell around the fiber, that is normally about 350-400 micron, one plastic shell. So practically the minimum wall thickness is 1.5 millimeter with one fiber inside and one plastic shell from each side of the wall. But we also have a special capabilities, special tools to print without plastic shells. In this case, the wall thickness will be 700 micron. Question from Bill. New materials will be available for shipping end of November. They are already available for pre-order, but we've launched the first production batch this month, and these new materials will be available for shipping since end of November. So end of November we will also have the new batch of printers, of machines that will have a small hardware upgrade. So there are no major changes in hardware except one, but I think actually quite important. So there will be two new interfaces, network interfaces, Wi-Fi and Ethernet available from the new batch of the machines. So if you're like ordering now, that will be already that should be already the machines from the new batch that will be available end of November. Adhesion. So yeah, that's a very good question. Obviously, the materials were designed to work together. They are both based on the PA12, so both have the same base material. The CFC PA has certain additives for lowering for decreasing viscosity increase in melt flow rate, and increase in adhesion to fiber, but it's also it was also designed, of course, to have a good adhesion to the external shell material, to the CFC PA material. Yes, question from Yannick. Yes, for the smooth PA, as it's a chopped fiber filled material, of course, there is a hardened steel nozzle needed, and on all the new machines that will be shipped together with the smooth PA, starting from end of November, there is a hardened steel nozzle instead of the brass nozzle on the plastic extruder. As the plastic nozzle is on the composer is the standard M6 E3D type nozzle, it's quite easy to get different types of either hardened steel or Rabi inlay nozzles. You can also get it from us, but it's available in most of the 3D printing shops. Thank you, Joshua. Could we use epoxy for plastic filament with A3? I'm not sure if I got the question correct. If you mean for post-processing, so if you can glue the parts with epoxy or cover the parts with epoxy after printing, the answer is yes. But if you want to use epoxy in the printing process as the filament, then the answer is no, because obviously the process, the co-extrusion process, requires a thermoplastic material. So the material that could melt in the hot end, that could melt in the hot end, that can flow through the hot end and then consolidate when cooling down. So you can use different types of thermoplastics, different types of plastic filaments, but epoxy is a thermostatic material, and it is not possible to use it as a plastic filament on our systems. However, the epoxy is still there. As you may know, the reinforcing fibers that we are using are impregnated with epoxy-based polymer. So that's why we call it a dual matrix material. Can you provide us with strength stiffness results and compare it to conventional made CFP parts? Of course, we have, actually you should be able to see it on the screen right now. So the reinforcing fiber itself has a 60% of fiber volume fraction, so the modulus and the strength is very high. For the reinforcing fiber, it's 100 GPa elastic modulus and 2200 MPa tensile strength. But when we print it with co-extrusion, we add another about roughly 50% of the thermoplastic material. So the fiber volume fraction is reduced down to 30%, and the actual materials properties, the actual properties of the 3D printed materials, you can see on the page. So the ultimate stress in fiber direction is 860, and the tensile modulus is 64 GPa. So it's roughly about 40–50% of the performance of the conventional autoclave grade composites. But the beauty of the process is that it's much more flexible compared to the conventional ones. So you can make a real complex 3D parts, you can make different types of reinforcements, and you can make lattices. You can have curvilinear reinforcements to reinforce holes, to reinforce joints. So there is much more flexibility in terms of optimizing the part structure, the part shape, and the part internal structure. And much more complex shapes are actually possible. So there is always a trade-off, as I say. Either you are using a high-performance material, but then you are limited in shapes, or you are using the material that has itself a lower performance, but you have much more options in terms of optimizing the shape and optimizing the internal structure. How flexible is the placement of the reinforced filament? Is it possible to freely define the placement in the slicer? That's a very good question. So in our software, it's actually a slicer that is geometry based. So all the fiber paths will be always derived from the perimeters. What you can do in Aura is define reinforced perimeters, any number of reinforced perimeters, or infill, which can be a plastic infill, or fiber infill, which can be solid or lattice. So there are a lot of options. And so there are actually 3 options for a free fiber placement that we have at the moment or will be able to offer in future. First option is we have a separate tool separately from Aura, which is called Nanogy Code. It's a plugin for AutoCAD type software, for 2D drawing software, where you can manually define the fiber paths and then convert it into a G code. That's the one option that we have at the moment and that we can offer to our customers upon request. But there will be 2 new options. So one will be available this year, later in December, in the premium package for Aura. It will be called layer masks. So it's a special instrument to be able to define fiber trajectories based on several bodies imported into the slicer interface. So there will be one model in the slicer that is used as a base model. Then you can import another supplementary model together with the base model, and there will be a possibility to create so-called layer masks, so that the fiber trajectories could be defined based on the Boolean or on the intersections of the 2 models. And this will be separately announced in December, and we will have I'm pretty sure we will have a separate webinar explaining and showing how it works. 0.4 nozzle is okay with the smooth PA, or do we need a larger one because of the CAF? No, the 0.4 is okay. So actually the smooth PA is working with 0.4, which is the nozzle maximum temperature. At the current systems, the maximum temperature is 300 degrees. What's about mechanical properties of the composite carbon fiber at temperature higher than 100 degrees? A very good question. So it really depends on the thermoplastic material that you are using. Which you are using to reinforce. So each plastic has different thermal properties. On the composer, I think the most high temperature that you can use is polycarbonate that can work up to 120, I think. Most of the materials, such as nylon, such as the PA or PETG, would not work over 100 degrees, but there is a slight increase of the performance at the high temperature when printed with fiber. But normally you should check the properties of the plastic what is the maximum temperature, maximum using temperature. Do you see any chance to work with the thermosetting resin? It's not so obvious question to answer. So basically, the technology that we're using, the composite fiber co-extrusion, it uses the thermoplastic as a matrix material and special reinforcing fiber as a reinforcement. So for the technology, it is important that the main matrix material is a thermoplastic. But there is a thermoset also inside there. So we are not using the dry fiber tow. So we are pre-impregnating the dry fiber tow with a thermoset resin. We fully cure it to get the stiff composite fiber, as we call it. And then we print it together with a thermoplastic. So the actual material, the final material, we call a B-matrix or dual matrix material, which has the thermoset inside the fiber tow and the thermoplastic between the fiber tows. Which damages most often happen with this technology, such as delamination, fiber breakage, resin crack, etc. There are also a very good question. So there is differences. So there are defects, like manufacturing defects, and that's maybe one part of the question. And the second part of the question is, what is the typical failure behavior of the material, of the 3D printed material? The failure behavior, of course, depends very much on the loading conditions, but typically that's the normal behavior of a composite material. So if it's if the fiber is properly loaded, then it will be the fiber breakage, of course, the dominating failure mode. And that's what we normally observe in most of the cases. The delamination can happen if the part is not properly designed and the part is loaded across the fiber, not along the fiber. Then, of course, it can delaminate and crack in certain cases. But yeah, it's not so easy to answer. So it depends, of course, on the part and how you load it. I'm not sure if that was the good answer, but at least that's what I can say at glance. The machine with all the hardware can be upgraded, so please write us to the support portal with this request, and then our team will answer how it's possible. Yeah, there is no information on the website regarding NanoCAD, so I recommend, for such questions, we have a support portal, one window for all requests for either our customers or our existing customers or our potential customers. Please write to support at anisoprint.com, write your email or submit it through the support form on the web page, and you will be answered promptly. So regarding the NanoCAD, I also ask you, please send us an email to support at anisoprint.com, and you will get more information about that. The CCF is impregnated with an epoxy-based material, so that's our special proprietary formulation that has certain additives to achieve good quality and good printability and good processability of the material, but the base material is epoxy. What about mechanical? I answered that one again. In the CCF filament, there is almost no porosity. So as it's impregnated with a thermoset, it's a well-known process. So most of the commercial fibers are sized, so have the sizing for epoxy, and epoxy has a good and it's quite easy to process with the fibers, and that's a well-known process. Normally the fibers are highly permeable with such formulations. So we are able to achieve 0 to 0.5% porosity inside the CCF, and 60 and maybe even higher, 60 percentage of fiber volume fraction in the reinforcing fiber. Yes, the last question from Olivier, some annealing recommendation. Yeah, most of the PA materials can be treated can be annealed to increase the properties. So also the smooth PA material can be annealed to increase its properties, and we can give you the recommendations on that. If you also, please feel free to submit your questions to support@anisoprint.com, and our support team will answer and give you the instructions. Can we use both the continuous fiber and chopped fiber together? The answer is yes. You can use the chopped fiber infused material on the composite extruder together with continuous fiber. However, we do not have too much experience internally doing that. So we cannot actually recommend you any settings or any benefits that you can achieve by doing that, but we will be working on that in future to see if it gives any special properties. It could, so it could provide some improved adhesion, and it could provide some improvement in interlaminar properties of the composite material, but it also can have some difficulties. So it's quite important for good processability and for good printability that the co-extrusion plastic has low viscosity. So with the chopped fiber infused materials, the viscosity is normally much higher, so there is a higher probability of clogging that would lead to the print failure. So that's why we are not currently too much investigating into that topic, but it's definitely interesting, and that's definitely something that you can do and test on your own. Question from Vishwanath A2. There was in the beginning, when we were planning our product pipeline, there was indeed an idea to have the 3 models for the desktop versions, A3, A4, A3, and A2. But eventually, it's not so easy to scale to that big format and stay in the desktop size. So actually, A4 was in the development phase, was transformed into what we call Prom IS 500 today. So there will be no bigger desktop system. For the bigger size, as big as A2, there will be only an industrial factory floor system available. Chopped carbon fiber filaments are just so much easier to print than regular PA. I'll never print anything without chopped fiber anymore. Yes, that's true when you are printing on plastic nozzle, but with continuous fiber, it is different. So it is also possible, but there will be much more issues in regards with the co-extrusion process. As I mentioned, there is a high flow melt required for better processability. So yeah, it really makes sense to print the chopped fibers on the FDM nozzle, but on the CFC, on the composite nozzle, it's better using as for our experience, it's better to use neat grades, uninfused grades. How much better is the PA smooth plus PA CFC in terms of strength and stiffness compared to your typical PETG values? It's not different. So all the properties are, as per the rule of mixtures, all the properties are mostly defined by the fiber. So if the fiber has the strength of 2000 MPa and then the plastic has the strength of 40 MPa and they are 50-50, then by the rule of mixtures, the input of the plastic strength is nothing compared to the input of the reinforcing fiber. So it doesn't really matter if you print with a plastic that is 40 MPa strong or 100 MPa strong. It will not affect significantly the strength and stiffness of a composite material in fiber direction, but of course it will have an influence on the transverse properties. Thanks everyone. And thank you for joining us. I hope it was useful, and I encourage you to check our new page, our new use cases, to check the training courses, and in case you have any further questions, please feel free to write us either to info@anisoprint.com or support@anisoprint.com, or me directly, Antonov@anisoprint.com, and we will do our best to answer all your questions and help you and support you in understanding our product and our technology. So thanks everyone, thank you for joining, and please follow us on the social networks, and there will be more announcements this year in the software field. As I said, there will be new premium features for Aura and new server features for Aura for managing the machines through the network. So these new products will be announced later this year, so please keep in touch with us, and thank you for being here today. Bye-bye.